about circles and the Pythagorean theorem. Okay, and so basically today is a lot of application-based problems where you're going to have to take everything that we've learned this chapter and you're now going to have to apply it. So first of all, we have the tangent conjecture. The tangent conjecture states that a tangent to a circle is perpendicular to the radius drawn to the point of tangency. And we've already learned this. Okay, this shouldn't be anything new. Basically just states you've got a right angle right there. You know you've got a radius there and you've got a tangent. And then we also have the following, angles inscribed in a semicircle conjecture. Basically, angles inscribed in a semicircle are right angles. Now remember, for it to be inscribed, this is what we're talking about. Okay. And so, since that's inscribed in a semicircle, remember that's half the measure, and we know that this entire measure here, since it's a semicircle, is 180 degrees. So we know that half of 180 is 90. Okay? So then now, let's go ahead and we're going to go ahead and look at our first example. All right, so let's go ahead and look at our first example. Here we go. It says if OC is perpendicular to AB. So OC is perpendicular to AB. Remember, that means that I've got a right angle right here. AB is 24 centimeters. So that means the distance from here to here is 24. What do you know about each of those halves? They're equal, and so each of these is 12. The reason why I know that's because it's perpendicular. Okay, cuts it into two equal parts. MC is 8. So that means this here is 8. Now that doesn't mean that OM is 8. Okay, understand that just because MC is 8 doesn't mean that OM is 8. And in fact, if you look at it, it doesn't even look like it's 8. Okay. And we need to find the diameter of circle O. So basically, if we find the radius, we can just take it times 2. So now I got to figure out, I have a radius right here, OC. That's a radius. I also have another radius right here, OA. Now look at what I've done when I've drawn that OA in. What have I created? A right triangle, because this is also a right angle. So let's think about something. OM, do I know what OM is? No, but I'll just call that X. Okay, so let's think, what's the distance from O to C?
X plus 8.
X plus 8. What do I know about O and C and O and A? They're equal, so really this is also X plus 8. So if I just take a snapshot of what I see there, OAM, here's A, here's O, and I know I've got M right here. So that's a right angle. I've got X here, I've got 12 here, and I've got X plus 8. So I'm going to use my Pythagorean theorem here. Pythagorean theorem in this case will state that X squared plus 12 squared, 12 squared, not 12x, equals x plus 8 quantity squared. So I'm going to solve that. Okay. I have x squared, which is just x squared. What's 12 squared? 144. Now with this x plus 8, what I'm going to want to do is write another x plus 8. And how do I multiply those together from last year?
First, outer, inner, last.
Yeah, FOIL. First, outer, inner, last. So I start x times x, and I get x squared. X times 8, and I get 8x. X times 8, I get
8x.
And then 8 times 8, I get 64. So now what I need to do is combine like terms if I can. And so I still have my x squared plus 144. I have equals x squared plus 16x plus 64. What do you know about your x squareds?
Cancel.
They cancel because we have 1 on each side, right? So let's go ahead and get rid of those babies. Now I have to solve it for x. So to solve that for x, what am I going to do?
Subtract 64.
Subtract 64 from both sides. So what's 144 minus 64?
80.
80 equals
16x.
16x. So now in order to solve that, what are you going to do?
Divide by 16.
Divide by 16. So what does x equal? 5. Now let's go back to the problem. It says find the diameter of circle O. So if I look, x here is 5. So really that means this is gone and I've got a 5 here. That means 5 plus 8 now becomes what? 13. Now I don't want a radius, I want a diameter. So I really want this distance here. Okay, this whole distance from here to here. So if half of it's 13, the other half has to be 13. And so what's the diameter got to be?
26.
26 centimeters. So this is one of those problems that you're going to, like I said, have to apply what you know. Okay, it's probably not going to just come like that. Let's look at another one. HA equals 8 root 3. Find the shaded area. Ooh, yeah, it looks good. So 8 root 3, that refers to this distance right here. What do I know about HT? It's 8 root 3 as well because, yep, and it's actually a kite because AR and RT are radii. Okay, so what I'm going to do, or what do you think I should do?
A and T are 90 degree.
Okay, A and T are 90-degree angles, I'll give you that.
You can make 2 triangles.
You can make 2 triangles. That's probably what I would do. Okay, in this problem, what I would do is cut it right down here, right down the middle. Okay, I can find the area of one of those and then just double it. Okay, so let's think about things. If this is 120, what is each of those little angles going to be? 60. So really this is 60 degrees. So essentially, I have a 90-degree angle here. I know it doesn't look like a 90-degree, it is. Okay, 60 degrees, R, T, and H, and this is 8 root 3. So in order to find the area of that triangle, I need to know this right here. So let's think back to our 30, 60, 90s. Do we remember those? What will this be?
8.
8, very good. So the area of one of those triangles will be 8 times 8 root 3 divided by 2. That's the area. You can put A there for you. Okay, so what is 8 times 8 root 3 divided by 2?
32 root 3.
Okay, I can cancel a 2 and an 8 right there, and so I have 4 times 8, which is 32 root 3. Now that's just for half of it, right? So I also need what?
Double.
To double it. So really my total area is 64 root 3. Now that area is this whole kite right here. So what do I need to do now?
Subtract the circle.
Subtract
Part of the circle.
part of the circle off. I need to subtract this right here. Okay, I need to subtract off this sector right here. So remember how we find the area of a sector?
Take A over 360, which A would be 120 times pi radius squared.
Okay, right. If you think about it, you've got an entire circle, correct? What's the area of an entire circle? Pi r squared. So let's just write pi r squared here. but I don't have a full circle. I've got a part of a circle. Okay? I only have 120 degrees of a circle. So what fraction of the circle is this?
1/3.
1/3, right? This would be like a third of a pizza. Okay? So I'm going to just take that times 1/3. And so what's my radius?
8.
8, because of what I found down here. Remember I found it down here? Okay, so I'm going to take radius, my 8, so I've got pi times 8 squared times 1/3. So what is 8 squared?
64.
64. So really I have 64 times pi all divided by 3. Now that's what the area of the sector is. So can somebody tell me what I'm going to do with this number and this number? Subtract them. So if you want to go ahead and get out your calculator, you're going to take 64 root 3. So if you just want to tell me what that is as a decimal, it's probably going to be easier. And then we're going to subtract 64 pi divided by 3. So what is 64 root 3? Should be something over 100. Or close to 100. So 64 times root 3, what'd you get?
111.
Okay, 111 point what?
Oh, it's
Yeah,
110.85.
110.8.
110.85, somebody else got that?
Yep.
Now what I need you to calculate is what 64 times the pi button divided by 3 is.
67.02.
Yep.
67.02. So go ahead and subtract those two for me, and what do you get?
33.
43.83. Okay. So you can see that these problems aren't going to, they aren't going to be super fast. You're going to have to take some time. Okay? Any questions on that? Okay, this is the last section we are covering in Chapter 9, so we are looking for a test in the next week or so. What I need you to do on page 509 is 1 through 8. Okay, page 509, 1 through 8.